Okay. Welcome everyone to the Enterprise Storage Integration webinar with OpenNebula and Pure Storage. Just quickly go over some introductions here, and we'll get started on the content, talking about some storage solutions. So I'll introduce both of us here. I'm Neil Hansen, the Senior Cloud Solutions Architect here at OpenNebula Systems. So it means I essentially do half the things at the company, from development all the way to marketing and everything like that. So been working in the company just 4 years as of last week, and excited to show you some of the new stuff we've been doing recently. And also Simon.
Hi everyone, my name is Simon Dodsley. I am Technical Strategy Director for Open Source at Pure Storage. I've been with Pure for 12 years now. Very excited to see any integration that anyone's doing with open source technologies and with Pure Storage, and I'm very happy to be on this webinar with OpenNebula.
Awesome. So kind of start out by why this partnership is so nice and cool, and how we're collaborating together. OpenNebula Cloud Platform is an enterprise cloud platform for you to orchestrate your virtual machines. Got a lot of advanced storage and orchestration built in. All the configuration is very flexible, so depending on what kind of information you have or what kind of infrastructure you already have, we can usually fit into almost any situation there. Of course, we have like policy and quotas with the users and their resource usages there. Easily scalable. You can just drop in more hosts, upgrade systems, add in more resources as we need to go. And of course, like stuff like live migration controls, all the VM lifecycle operations that happen day to day. And it's important for Pure Storage to have collaboration with us because it's a very useful and mature storage solution. And so maybe expand on that a little bit.
Yeah, I think Pure Storage, if you're not aware who Pure Storage are, we are, we've been around for about 15 years now, and we are enterprise flash storage, all flash storage array based on NVMe, and I'll go over that a little bit later on. But the thing about it is it's flash technology. It is very low latency all the time. We've got great snapshotting and cloning technology, which works really well with an OpenNebula cloud. One of the really nice things that we have is the ability to do non-disruptive hardware and software upgrades during the working day with zero impact on any of the workloads that are coming from any of the applications using that backend storage.
Yeah, that's great. And all that stuff helps you administer your cloud resources a lot smoother, less downtime. So yeah, SAN storage is useful in OpenNebula, of course, because it's shared. All hosts on the network can access it and change things. So that makes migrations very easy. We don't have to move any storage around. We just kind of put the VM up somewhere else and synchronize the memory. Also means the storage is separated from host. So if a host has a disaster, then the storage is still safe and kept somewhere else. That allows us to do high availability, which is essentially similar to a live migration, but it's just the storage is available elsewhere, so we can bring up the VM when it goes down. And I mentioned flexible configuration here before. You can have multiple different connections to it. Of course, I see with here we have the NFS or iSCSI. Kind of go over both of those a little bit. That allows you to expand and scale the storage a lot easier as well, because it's separated from the host. You don't have to do any separate thing like that. And it simplifies some disaster recovery if some of your hosts fail, or even there's some disaster recovery services inside of the SAN as well. I'll just quickly kind of go over these different connection styles we have for connecting to Pure Storage. The main one that we recommend for maybe more complex clouds or more complex management systems is the iSCSI connection using the LVM within provisioning. That'll, you can over provision a little bit your storage that way with keeping the thin provision going in. It creates a shared volume group across all the hosts, and then each virtual machine gets a logical volume pool, and then each disk gets a logical volume inside of that pool. Allows us to take snapshots of each of those disks and keep them contained and organized that way. We only activate the logical volumes on the host that needs it at the time. All that's done over a multipath connection to the SAN with 2 or 4, how many connections you would like for your multipath. That gives the host side LVM control as well, so that all the metadata and stuff is controlled by the host. And of course, as like I mentioned earlier, it's predictable latency because of Pure Storage array. NFS, bit simpler design, essentially, a shared file system, network mounted file system. So it's simpler. It's a file per disk rather than a logical volume for a disk. It can be raw or QCAT2 format, but you need QCAT2 format to take advantage of more advanced things like snapshotting, QCAT2, like the sparse files and everything like that. Some important things about the iSCSI LVM thin is oftentimes people already have a SAN solution. If they're moving into OpenNebula or they're changing vendors or something, it allows you to kind of use what you know, so makes it simple to manage in that way. With LVM thin, you're used to taking snapshots in your previous solution, easily snapshotable. They're quick, essentially instant from all of our testing, and then they can also be restored quite quickly. And beyond that, if you've already used Linux in the past before, we're all operated on top of Linux, and all of our interactions are with Linux and using the iSCSI protocol here. So if you're used to that kind of stuff, then it's all going to be the same for you when you end up coming over here. All right, we'll move over Simon for a moment.
Yeah, so just a bit more about the flash array, which I say is an all-flash NVMe based storage solution. There are multiple types of flash array. We have the C, we have the X, we have the XL, basically designed to give you the storage that you want for the use case that you have. So you can be capacity centric, which would be like the C model array, or they would be for something like an XL or an X for the performance related storage. These arrays are physically the same. It's just the type of flash technology that we're using inside them. It's the same operating system and all of that sort of stuff. Same GUI, everything is the same. It's just, again, the different types of flash technology that we use within the platform. Today, as you see, OpenNebula are using iSCSI and NFS. The flash array does support multiple protocols. In fact, all the protocols you could probably think of are there, including all of the new NVMe supported technologies as well. I believe that Neil will be mentioning something about some enhancements for protocol support later on in the webinar. Now, the thing to remember about flash array is that every volume that is created is by default thin provisioned anyway. So we're doing thin on thin to a large extent when you're talking about the OpenNebula solution. And also every volume is DARE. So we have basically it's encryption at rest. Okay, so every volume is fully encrypted on the array, and it's very difficult to do anything with that volume if someone tries to steal one of the modules, you cannot get to that data without, it's basically encrypted. You can't do it. So the snapshot technology and the cloning technology we use something called redirect on write rather than the copy on write technology that used to be around. This basically means that any snapshot or any clone is absolutely instantaneous. It is incredibly space efficient and also very, very fast. So we can do things really fast. You make a clone of a massive volume. You can instantly access that clone and be ready to read and write from that clone volume instantly. That gives us the ability, using those sort of redirect on write snapshots and clones, to get really good data reduction numbers on our flash array. The data reduction and the compression algorithms we use, which are on all the time, give the ability to have really, really high data reduction rates, depending on how you're utilizing the array. Across the board, on average, without including thin provisioning, we're seeing around 5-to-1 data reduction rates. You start adding in the thin provisioning numbers, you start adding in the possibility of using the clones of, let's say, a QCOW image or something like that, and you're multi-cloning that QCOW image, you're going to increase that data reduction rate to a really high number. The array is designed to work with all operating systems, whether it be a Linux-based solution or, not for OpenNebula, obviously, but we have all the other proprietary different systems out there, including strange things like OpenVMS and those sort of things. Each host can have a personality. The default one is absolutely fine for Linux. It's designed to work with Linux. And as Neil mentioned before, we have full multipathing support. That is included by default in most Linux distributions. So if you have multipathing software installed, the config file for the pure array is already in the default multipath config file. So it's very easy. There's nothing really you need to do. The only thing that we would potentially say is maybe check the UDEV settings, go to pure support site, and there's a lot of information about making sure the UDEV rules are set up correctly. But apart from that, it's a matter of plug and play.
Yeah, absolutely. That's been my experience with it as well when I've been testing around with all the stuff, all of our integration. But one question I had really quick for you, Simon, was is there any impact on doing LVM thin on thin provisioned Pure Storage?
We're not aware of any impact at all. It's the thin on thin should be absolutely fine. We've never seen any issues with that.
Awesome. Yeah, that's kind of what I've been seeing as well. So I don't double check, make sure. All right, I've recorded a short little demo here. It'll be about 5 minutes long, and I'll narrate the whole time. But gonna review the device connection both from the. I'm just gonna quickly show the Pure Storage side of things. Show it's connected to the host. I'll show you the iSCSI connection. I've already set that stuff up, and then we'll create the data store in OpenNebula, and then create the LVM metadata around that, the physical volume and the volume group, and then I'll download an image and instantiate and snapshot the disk so you can kind of see the inner workings of the system as well. So I'll have to change over to the video here. All right, so yeah, we're seeing Pure Storage here. I just have show it's connected to the one host that we're using. Just a 500 gig array that I've named LVM thin. And then here on the host, I'll check the iSCSI connections here. We have the 2 nodes connected for the double multipath, and then we have the sessions that are active for those as well. And check the multipath mapping there. You can see the devices are connected. Where in DM1, you can see it's a pure flash array as well. And even in LS block, you can kind of see these as well. I think I even show the fdisk for SDA here to show that it shows it's a flash array there as well. Yeah, see the correct size and stuff there on each of the multipaths. So here in OpenNebula, now we'll go and start off by actually creating a system data store here. The system data store we create first, both because we need to know the ID of the data store to make the volume group. And then we also need to, well, we don't need to, but it's useful to make the image second because you can assign the compatible data stores while you're creating it rather than doing after. Enable LVM thin here, I'm highlighting is it's on by default when you create the LVM data store. So I don't need to think about like forgetting that it's there. So we can see the system data stores here in the data store list. We'll quickly make the image data store too. It's going to be essentially the same process, except for after I select the, after this one, the configuration, LVM thin is there, but we'll also select the LVM system to be the compatible system data store. And that's all finished. And then now we have some of the information. We'll show that they're both there. And we have these data store created. It has all the extra attributes sitting in there. You can see the LVM thin is enabled on both of those. And then we just are going to create the devices here now. And clear out the screen so it's a little bit nicer to see. But we can see right now there's the only physical device is the one that's the NVMe that's on the system itself. And we'll create from the dev mapper empath A we saw earlier. And then we can create the volume group from that using the device. And you only need to do this once when you set it up. You don't need to do it on every single host. The metadata spreads across, of course, when it scans. And now we can see that we have 2 volume groups and 2 physical volumes here. We can look at some more information about the volume group itself, see how large it is, how many extents it has, and everything. And we can see right now there are no logical volumes besides the one we have on the system itself for the home. We'll go and download an application here. I think I just do an Alpine because they're quite small. Alpine 3.2. Yep. We'll just tag it with the LVM to make sure it's differentiable in the list of images here. Make sure we select the LVM image data store, and then it's going to show you the IDs in the bottom right there for the templates. We can go in there and we can see the images being downloaded right now with the yellow, but it's only like 128 megs, so it's green and done. It's not quite made it here yet because in this image data store, we store them actually as files, and then we move them over when they're used. Unused files, unused images aren't taking up space on the storage array for this case. And then I'll just make a quickly instantiate a VM with some basic things. We can see the disk there is set to be from the LVM image data store. And this one should boot up pretty quick. It's pretty small VM. And meanwhile, while wait for that to boot up, I'll show you the list here. This is the actual physical file for the image for the virtual machine where we take it from. And then now we can see the LVM has a logical volume pool here for VMID 21. So LV121 pool. And we have the LV121.0 in there as well. And that VM should be going by now. So we can at least go in here and we can take check the VNC first. Classic, make sure it's actually running. And it is. We're here at a login screen, so we can go and create a snapshot from the disk itself. And you'll see the buttons will change very quickly here. They'll go off and back on for the create or resume button there. It just instantly essentially creates the snapshot. It's going from running to hot plug to running. Snapshot there is instantly made from LVM, and it's now visible in the pool. And you can see some of the data reduction % there. So, all right, and that's the demo essentially. That's how fast you can set up an LVM data store and get running in 5 minutes or less, really. So we can change back over to the slideshow. Okay, and then that's the main demonstration. There's one more thing I wanted to kind of talk about a little bit before we go into questions. Is just we have a lot of VMware customers who are trying to find other alternate solutions to stuff, and especially if you're one that uses Pure Storage already, it's very easy for you to come and try us out, see if we can fulfill all the needs. There's many stuff that we cover for VMware World. They have VMFS and NFS shared data stores. We have iSCSI LUNs. We have NFS as well. We have multiple different shared storages. They have the storage vMotion, and we have some ability to move that, and really shared multipath access gets rid of necessity for vMotion most of the time. They have the hypervisor-based snapshots. We do the LVM thin snapshots. And vSAN, they're policy-based storage, and we can do LVM on any SAN. We don't need any specific vendor plugins. Sometimes they have vendor plugins required for certain storage solutions. Our workflow is the same for all arrays. Doesn't have to have massive changes there. And then the whole storage lifecycle is controlled by Elite vCenter, whereas your storage team gets to control the whole storage lifecycle instead. And we're going to have much more deeper control rather than just having the box take care of everything. And so that means essentially you don't have a brand new storage stack to learn. It's just the same stuff. We utilize exactly what's already there. We're not trying to recreate the wheel. Some of the future plans here. I know there's been a couple of questions about Fiber Channel, and that I didn't include it on here necessarily because we're still working on the analysis and development of the initial stages of that. But that is something we do have planned. Things that are a lot closer right now are going to be the native Pure Storage integration, where we'll use the REST API and create volumes on the fly for each virtual machine. We're going to have a full LVM data store as well. So if you wanted to store the images on the LVM, if you're going to be deploying and terminating VMs rapidly, it's a little quicker to just copy the logical volume over. So you have a full LVM where the image and the system data store are housed in the same SAN, so we can easily copy stuff over. And then some other stuff planned for a future version. It's going to be storage live migration, so you can move the disks from one data store to another while the virtual machine is actually running. And then with that is going to allow us to do some storage disaster recovery services as well. And yeah, if there's anything else you wanted to cover, Simon, and otherwise we can start building a few questions.
Yeah, I mean, if you just go back to your future plans, I think the one thing that we need to make sure is that the current integration with the Pure Storage flash array requires manual intervention on the flash array. So you need to create the volume, you need to create the host, which has obviously been pre-done. But I think the important one is this native integration that's coming. That's going to be, as you say, leveraging the REST APIs. So it will automatically create the volumes for you, whatever you need to do to those volumes. The REST APIs for the flash array are fully featured. So literally anything you can do on the GUI or the CLI, you can do it via API as well, because we are basically API driven and API first as a platform. So I just wanted to cover that really.
Yeah. I mean, I'm happy to expand upon that because it's going to be me. I'm gonna, fortunately or unfortunately, it's going to be my job to do that. And but we've been reading a lot of the API, and I have some little test scripts here and there, and the API seems also very simple to use as well. It's not super complicated, and I can actually get a lot of stuff done with it pretty quickly with not having to, like, I don't know, do a ton of research. The documentation is very, very good so far. So yeah, the only thing you'll have to really provide to it is connection details, and then OpenNebula can take care of the rest after that.
As actually interesting question just come in. I don't know whether you want to answer that, Neil, regarding direct snapshotting on the flash array volumes.
Yeah, I mean, with the integration, yeah, that's part of the big reason why we want to do the integration, is because we can do snapshots individually for each disk or each virtual machine that way on the storage array, on the pure storage array, rather than having the host handle the snapshotting effort with the copy on write stuff. Then instead, pure storage could do redirect on write much faster, much more performant. The pure storage integration, we would love to have it for 7.2. That's a goal. Hopefully, we can get stuff, at least the testing stuff done first, so we can get it there. But yeah, 7.2 would be ideally when all these are hopefully going to come out, if everything goes as planned. Yeah, of course. Any other good questions? Good questions coming in so far. I know I talked a little bit about the fiber channel stuff, but we just got to really do some testing around it. We just need to get a little bit some other hardware to make sure we can cover all bases. And then once we get that fully tested, then we'll feel more comfortable releasing something for fiber channel.
And I think the nice thing about the flash array is the protocol is irrelevant largely. We support all the protocols, and an API call to create a volume against an iSCSI host or a fiber channel host is exactly the same. Right. So it makes no difference really.
Yeah, and we're developing these newer storage integrations, and with we have like the iSCSI as a separate library, and the fiber channel is a separate library. So as we do we'll just have to do the pure storage API stuff, and we can hook it into our existing device management libraries.
I think another thing, I don't know whether OpenNebula are considering this yet. One of the other cool features of the flash array is our replication technology. Mm-hmm. So that could be something that could be, OpenNebula could look at in the future, is giving you that failover capability by having replication between multiple arrays. So we support multiple types of replication as well, but whether it's asynchronous and fully synchronous, and also something that's effectively what we call near sync. We call it active DR, which is effectively near sync. So there are lots of different opportunities for doing replication capabilities as well.
I mean, yeah, I saw some of that stuff mentioned, but I think as with our development of the storage disaster recovery, that's going to be really useful. It's going to make that part of it very simple for us, for sure. As I guess the live migration would be another thing there. If you had multiple pure storage arrays, you can do the storage live migration that way as well.
Yeah, and it's something we're continually adding and developing to, is our replication capabilities and making it more seamless. And we're even coming up with a new product. It's actually just been released. It's called Fusion, which is effectively a front end to a fleet of arrays. So you would provision, it would even work with OpenNebula. You would talk to this Fusion front end, and Fusion itself would work out the best place to create the volume that you're wanting to create based on workloads and all those sort of clever things.
Yeah, that'd be a good deeper integration to do at some point for sure. Okay. Do we have anyone who has any question about OpenNebula or pure storage or any of the integration plans we have or anything around that? I know we covered a lot of it, but just want to double check, so we have a few extra minutes here because I speak too fast. So I rush through a lot of my stuff. Okay. Yeah, I guess yeah, I mean, if you guys ever do end up with some more questions, okay. I know we got another one from Erwin here.
Okay, so that's a support question. Okay, so FlashStack. So for those of you who don't know what FlashStack is, it is it's a rack solution with a whole bunch of Cisco UCS and Pure put together, defined and approved by Cisco as a racked solution. OpenNebula versus Pure connection. I guess the initial call would be to OpenNebula, but then Pure is obviously fully supportive of this, and you can log calls with our support organizations as well.
Yeah, it's my understanding if you have one of the Pure arrays, that their support is also very helpful. We can definitely do some troubleshooting there with the connection on it, with this getting iSCSI, whatever, if there's some weird connection issue there, stuff like that. Yeah, I mean, our support team is very well trained. They're good engineers. They have a deep Linux knowledge, so they can generally help with some normal basic stuff. Or anything more advanced, then yeah, I guess you go talk to Pure.
Yeah, we would support that under the FlashStack contract anyway.
Yeah, cool. All right. Maybe give another minute or two just to see if there's going to be someone comes up with a question here, but
someone's typing a really long question, maybe.
Maybe it's gonna. We'll see. I think for the most part, I think people mostly got the answer. I was going to say for the stuff, I guess I'll move on to here. Yeah, if you have any questions or whatever, you can always contact us for more information about OpenNebula. We also have our forum, our support forum. Sorry, it's a community forum. People get support through there. People also have various questions, and sometimes we record issues and stuff there. Feel free. Also, our public GitHub repositories. You can, if you find an issue, you can submit there. You can fork, and you can contribute even to our OpenNebula stuff, OpenNebula repositories, and yeah, our documentation there on the screen, docs.opennebula.io. If you want to find more information about that, and then where should they go for Pure Storage, Simon?
For Pure Storage, just go to our website, purestorage.com. If you are a Pure Storage customer, you've already got a support contract with us. You can raise calls at our support email that everyone knows, or if you're a Pure customer, you're going to have access to our SaaS front end, which is called Pure One, where you can log calls automatically as well.
Awesome. Yeah, and so I think that pretty much covers it. On this ending slide here. Yeah, unless there's anything else you want to say, I think we can wrap this up, Simon.
Yeah, no, it's been a pleasure being on the webinar with you, and thank you very much for inviting me.
Yeah, awesome. It's been great to have you. I'm glad to have someone from Pure around. We can actually have a good back and forth here, talk about useful things. Awesome. Thank you so much, Simon. And go wrap this up now.
Thanks a lot.